Hey y'all, before we get started today, a little question for you to think about first. If you collected information about the age and the height of children and you made a scatter plot, do you think, without making it, it would have a positive correlation, a negative correlation, or no correlation? Think it through. Pause here, give it some thought. Don't make it, just think about it. And when you're ready to go, get that math notebook ready and unpause. All right, hold that thought. I'm going to come back to that one with some others. And that's what I want to teach you today is how to predict what kind of correlation two statistical questions would have without actually making the scatter plot. Last kind of scatter plot skill here is to predict, like, what if I made one? What would I expect to see? So make this the next title. It's a long one in your math book, and then you know what to do after that. Unpause, clear those distractions, and here we go. So talking about correlation for a long time, positive correlations are when one variable goes up, so does the other. Negative correlations are when one variable goes up, the other goes down. You can also think about those in terms of slope. You know, if the line of best fit has a positive slope, then there's a positive correlation. If it has a negative slope, it's a negative correlation. And don't forget, there are cases when there is no correlation and you can't make a line of best fit. It's just not possible to make one if the two things aren't related. And so what we're doing today is predicting, will something have a positive or a negative or no correlation without actually making the chart. So I asked you this first one, what sort of correlation do you think you would find here in the relationship between the height of the child and the age of a child? If I ask you predict, is that going to have a positive, a negative, or no correlation? Which one's it going to have without making it? And some tips for this. So first, as you'll notice on that first slide, I actually drew X and Y axes to help me visualize it. So I'm not going to make the whole scatter plot, but it does help me to kind of say, okay, age and height, and start to think, what's going to happen? Okay, as a child goes from being, 1 to 2 to 3 to 4 to 5 to 6 to 7, where would I expect to see the heights go on here? And it's a bit easier for me to visualize it if I draw my X and my Y axis. So, okay, with a 4-year-old height compared to a 2-year-old, what would I expect to see? That's my first tip. Second tip is to just ask yourself the correlation question. As one of these increases, do I expect the other to also increase, to decrease, or to be random? So just thinking logically, as age increases, do I expect height to increase, decrease, or be totally random? I feel like I expect it to increase. I'm used to kids getting taller as they get older. Usually, though of course not always, this is statistics, older kids are taller than younger kids most of the time. And I wouldn't expect it to be random. So those make a lot of sense to me to do those two things. So this one, I think I would say I would expect a positive correlation. I think as this goes higher, I would expect this to go higher too. That would be my prediction. What about this one? Temperature versus number of customers ordering soup for lunch. Well, let me take my advice here. First, draw my axes. I'm going to erase what's on them. But I'm going to put temperature down here. And I'm going to put number of people ordering soup here. And I'm just going to think about it. Okay, as the temperature went up, I don't know, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees. What do I expect to happen to the number of people who might order soup? And then I can also ask myself this question. As the temperature increases, would I expect the number of people ordering soup to increase also? To decrease? Or to be totally random? My logic personally tells me the warmer it gets, as that increases, less people are going to buy soup. I think soup is something people like to eat when it's cold more than they like to eat when it's hot. So I think On cold days, I would expect to see more soup. On warm days, I would expect to see less soup. And I think I would expect to see a negative correlation. Last one, shoe size versus reading level. All right, let's make the axes. What kind of correlation would I expect to see between shoe size and reading level? So shoe size, here we go. What's a low shoe size? Maybe 5, 6, 7, 8, 9, 10, and so on. And then reading level here. This helps me visualize it. Okay, as the shoe sizes get bigger, where would my mind expect to see the reading level points? As shoe size increases, do I expect reading level to increase? Well, I don't know what your shoe size would have to do with the reading level, positive or negative particularly. I don't think, like when I think through members of our class, doesn't make sense to me that people with bigger shoe sizes would have higher or lower reading levels. So I would probably expect this one to be random, which would be no correlation. They just don't seem like things that have anything to do with each other to me. All right. Go ahead and copy these down. We'll do these three together. Here are the examples. Here's my advice. So unpause when you're ready to go. The advice is just to make these easier to do. All right, size of car versus amount of gas it uses. So as we imagine cars getting bigger and bigger and bigger, I don't know exactly what unit or what measurement I would use for size of the car. So I'll just kind of do like, tiny, small, medium, big, huge, I don't know, something like that, where I'm like getting bigger and bigger and bigger cars. And then gas up here. How much gas do they use? So as one of these increases, as the size of the car increases, do I expect the amount of gas it uses to be more and more, to be less and less, or to be random? In my experience, bigger cars, way more, and they require more gas to run. So here for me, as the car gets bigger, I would expect the amount of gas it uses to be more and more. I would expect the small cars to kind of be down here, low gas. I would expect the huge cars to kind of be up here, more gas. I think I would expect a positive correlation there. Let me erase and go again. What about outside temperature versus your social studies grade? Okay, so let's go temperature down here. So like 40 degrees, 50 degrees, 60, 70, 80, and then your social studies grade up here. So as the temperature increases on warmer days, do I expect your social studies grade to be higher? Not particularly. Do I expect it to be lower? Not particularly. Sounds pretty random to me. I don't know why the temperature outside would have any effect or any relationship with social studies grade. This I would expect to be random, so this I would expect to have no correlation. I'm not sure what those would have to do with each other. Could be wrong, but that would be my most reasonable prediction. All right, last one. Slope of a hill versus a runner's speed going up it. So as a slope of a hill gets more and more, so we talked about slope of lines, maybe I'll think of measuring it like that. Slope of 1, slope of 2, slope of 3, slope of 4, slope of 5. What would I expect to see the runner's speed be on bigger and bigger hills? Well, let's see. As I expect slope to get steeper, do I expect runner speed to increase? I don't. I've run up a hill before. It's harder to run fast up a hill. So I would actually assume the opposite. I would assume that on a lower slope hill, runners would be faster. And a higher slope hill, runners would just be slower. And I would probably expect to see something like that. I would expect to see speed decrease as the slope gets steeper. I would expect a negative correlation. That's all predictions, y'all. That's how you make predictions about the slope. Oh, I'm sorry, about the slope. About the correlation between two variables without actually making the chart. Just a way to think it through, use some logic, and how do I expect them to be related? Hope this made tons of sense. Go back and review if it didn't, and I will see you tomorrow.